So this is the 2016 Junior Cert Higher Level Paper 2 and we're looking at question number 3. Table 1 on the right shows the percentage of female members of Parliament in each of the current 28 EU countries in 2005 and 2015. The figures are given in increasing order for each year. So we can see the table here for 2005-2015 and the percentage of female members in Parliament for 28 different countries. So each row here is a country in the two different years. So you can see it goes right down to the end there, 28 countries altogether. Part A says, find the value of the median of the upper quartile from the 2015 data. Fill your answers into the table below. The lower quartile value was already filled in. Okay, well, we have the lower quartile, so we're looking for the median and the upper quartile. Now, if we know that there's 28 EU countries, when you divide 28 into quartiles, divided by 4, we get 7. So we can see then that after 7 values, so 2, 3, 4, 5, 6, 7, that's the lower quartile. In there is the lower quartile. So we can see that it's halfway between 19 and 20, which is our 19.5%. So the median value will be another 7 down. So it's 1, 2, 3, 4, 5, 6, 7. So that's going to be our median value, which is the middle value. So the middle value is half between this 26 and that 26, so that's going to be 26 as well. If the numbers are the same, it's just 26. And then our upper quartile will be down another 7. So we're going to go 1, 2, 3, 4, 5, 6, 7. So that's going to be our upper quartile. So halfway between 36 and 37, which is 36.5% for the upper quartile. Okay, so part B, explain what the value of the lower quartile of the 2015 data means in this context. So the lower quartile for the 2015 data, which is 19.5%, well, that means that in one quarter of the countries, that's these bottom 7 here, less than 19.5% of the members of Parliament were female in that year. So in other words, all these numbers, but definitely less than 19.5%. So that's just what we need to put down. In 1 quarter or 25%. You can write this whatever way you feel comfortable, but in 1 quarter of the countries, less than 19.5% of the Parliament members were female. In 2015. Something to that effect would suffice, but that answer would be correct. Okay, part C says fill in the grouped frequency table in table 2 below. So here we have the percentage of female members of Parliament, and it's in groups now from 0 to 9, 10 to 19%, 20 to 29, and so on. And here's the different years. So we're going to put them into groups. So from 0 to 9 for 2005 and 2015. If we look back, we can see here there's 2 from 0, there's 2 in 2005, but there's none in that group for 2015. So we have 2 here and 0 there. So then we're looking at the 10 to 19 grouping for both years. So if we go back, we have 1, 2, 3, 4, 5, 6, 7 in 2015, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for 2005. So that's going to be 10 for 2005 and 7 for 2015. Now we're looking at the 20 to 29 group. So the 20 to 29 group, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in the 2015 group. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 8 in the 2005 group. So 8 in 2005 and 10. And now we're going to look at the 30 to 39 group for both. So 30 to 39. For 2005, we've got 1, 2, 3, 4, 5, 6, 7. And for 2015, we've got 1, 2, 3, 4, 5, 6, 7, 8. So 7 and 8. And finally, the 40 to 49 group. In 2005, we have 1, and in 2015, we have 1, 2, 3. So that's 1 and 3. So part D says, based on the data in table 2 up here, use mid-interval values to estimate the mean percentage of female members of parliament in 2005. Give your answer correct to 1 decimal place. Okay, so we're looking at 2005, which is this data here. And we're going to use mid-interval values. So if the interval is 0 to 9, well then the mid-interval value there for that would be 4.5. Mid-interval value between 10 and 19, so that's halfway between 10 and 19, so that would be 14.5. You can just add the two numbers and divide by 2 also. 20 to 29, that would be 24.5. 30 to 39 would be 34.5, halfway, mid-interval, and finally 44.5. So they'd be the mid-interval values. I'll just highlight them in a different colour, so that's our mid-interval values there, 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 and there. So when we're estimating the mean percentage, as soon as we use a mid-interval value, we're estimating. So for 2005, there was 2 countries in this group. So to find the mean, we're going to multiply 2 by 4.5, and we're going to add to that 7 times 14.5. So this mid-interval value is the best estimate for this group from this table. So then we're going to have, sorry, that was not 10 there. Mistake there. I'm looking at the data for 2005. It wasn't 7, rather, it was 10. So there was 10 at 14.5. There's 8 at 24.5. There's 7 at 34.5. And there's 1 at 44.5. So we're going to add all of those up, and we're going to divide them by the number of countries, because we're finding the mean, so we're going to divide that by the number of countries. The number of countries, so all of that multiplied and added, all of it gets divided by the number of countries. And there's 28 countries, we know that from the question. So when you put all of this here in the brackets here into your calculator, you get 636. So that's divided by 28. And that gives us 22.71. On it goes. But they want the answer correct to 1 decimal place. So if it's 1 decimal place, we look at this one here. Does that affect the 7 in front? No. So it's 22.7. That's our estimate for the mean. And that's a percent. And that's the end of part C. Part E says, using mid-interval values from table 2, Tom estimates that the mean percentage of female members of parliament in 2015 is 27%. Using the figures in table 1, the actual mean percentage in 2015 is 26.86%. Explain why these two values are different. Well, as I was saying, the mid-interval value assumes that every value in that interval is the same, which is not the case. So that is why the values are different. So we just write that down. Mid-interval values assume every value in a given interval has the same value. The actual values are not the same. So if you write an answer like that or something to that effect, you'll get full marks. Part 2 says, write the error in Tom's estimate of the mean as a percentage of the actual mean and give your answer correct to 2 decimal places. Okay, well, the error would be the 27%, take away the 26.86%. So that's the error. And that leaves us with 0.14%. That's the error, 0.14%, but they want that as a percentage of the actual mean. So if we're going to write it as a percentage of the actual mean, we're going to write 0.14 as a fraction of the actual mean, first of all. So the actual mean is 26.86 rather. And to convert that then to a percentage, you would multiply by 100. So when we put all of this here into the calculator, we get 0.521, and the decimal goes on. But we want this to 2 decimal places. So we're going to look at the third digit after the decimal. Does this 1 affect the 2 in front? The answer is no. So that would be 0.52%. And that's the error as a percentage of the actual mean. Okay, so finally we have part F of this rather long question. Display the data graphically in a way that allows you to compare the data for the 2 years. Label your graph clearly, show any calculations that you make, and you may use the data from table 1 or 2. Okay, so, well, we can use the table 1 or 2, so there's a number of graphs that you could do here. I'm going to use the data from table 1 here. So table 1, I'm going to use the actual data for all the 28 countries for each year, and the best way to compare these, I think, would be with a back-to-back stem and leaf diagram. So that's the way I'm going to do it. So we can see here that the values range from 9 and they go up to the 40s. So that's why I'm going to lay my back-to-back stem and leaf diagram out. It's going to go up to the 40s, so it's from the single digits to the 10s, to the 20s, to the 30s, to the 40s. We don't need to go any further than that. So I'm going to have 2015 over here, and I'm going to have 2005 over here, and then I'm just going to fill in my values. So they're already in order, which is nice. So for 2015, there's none in the first group, but then I have 10, 13, 13, 14, 16, 18, and 19 in the first group. So that would be 10 would be a 1 and a 0 to give me the 10, 13, 13, 14, 16, 18, and 19. There was none up here. And for 2005, there was 9 and a 9, and then 11, 12, 12, 12, 13, 13, 16, 17, 17, and finally 19. So when you fill the stem and leaf diagram in like this, when you're going to the left though, you start with the smaller number in close to the stem. So that's going to be our 11, the 12, the 2 more 12s, 2 13s, 16, 2 17s, and the 19. And then after that, I'm not going to keep going back and forth, but when you fill it in, eventually it will look like the following. Your 20, 20, 23, another 23, 2 24s, 2 26s, 28, and a 29. And the next level we had a 31, 31, another 31, 36, 3 37s, and a 39. And then in the 40s we had a 41, a 42, and a 44. While in 2005, in the 20s we had a 20, another one, we had 2 21s, 21, 21, 3 22s, and a 23. And in the 30s we had a 33, 34, a 35, a 36, 2 37s, and a 38. And then we just had 145. So just be careful when you're doing a stem and leaf that you keep the numbers lined up correctly underneath. And don't forget, with the stem and leaf diagram, you must have a key to show how the diagram works. So my key would be key that a stem of 2 and a leaf of 20, well, that means 20. There's my key. You must have that for full marks. That's one of the graphs you could do for table 1. There's other graphs. You could do a pie chart, you could do his bar chart, or a line graph if you wanted, but this was probably the easiest one. And that's the end of the question.